In this video, we are going to learn something called the distance formula. So, distance is defined as the amount of space between two set objects or points. So, let's do an activity. Let's say if we wanted to find out what the distance is between these 2 points that are plotted, how might we do so? And I encourage you to pause the video and think about it, because you do actually have the tools to be able to solve for this distance if you watch previous videos of this math course. And assuming you have given this a go, a couple minutes at least thinking about it, see if you can come up with it, let's go through this together. So notice that this distance makes a perfect line. But also notice, let's say, I wanted to find the slope of this. So, but this time I'm going to go down, and then to connect the point, I'm going to run. So we have the rise and the run. But notice, this looks awfully familiar to something we've seen before. What does this create? It creates a right triangle. And what is directly across from this right angle? That's our hypotenuse, side length C. And let's say this is side length A and B. So to find the distance, we can actually just apply the Pythagorean theorem. And to find the distance formula, we're actually going to use the Pythagorean theorem to do so. So to find side length A right here, how might we find that? Well, if we take, so because this is the height, we are worried about the difference in our y values. So we're going to take this y value 5 and subtract it by 2. So we're going to get 3. So this side length is 3. So A equals 3. And then B here, to figure out what B is, well, we got to find the difference in our x values. So we're going to take our x value 5 up here and subtract it by the x value down here, which is 1. And 5 minus 1, well, that's just 4. Now, but how do we actually make this into a formula, though? That's the question. Well, to make this into a formula, think about it like this. When we can say that this is, down here, this is x1, and this is y1. Up here, this is x2, and this is y2. So how did we find this value here? Well, we took y2 and subtracted y1. So here, we took y2 and subtracted the value y1. And then down here, what we did is we took the x2 value and subtracted the x1 value. So we took the x2 value and subtracted the x1 value. But recall, the Pythagorean theorem is a squared plus b squared equals c squared. So this is side length b, but b is squared. So we're going to need to square this whole thing. And same thing here. We're going to need to square that whole thing. So what might the distance formula be? Well, let's start deriving this, because we are actually deriving the distance formula right now using the Pythagorean theorem. So we have a squared, which is, that's actually, because we can interchange a and b, actually let's just say that this side length is b and this side length is a. So we have a squared, which is x2 minus x1 squared, and then we're going to add b squared, which is y2 minus y1, and we square that, and this is all equal to c squared. Now, we want to know the distance, right? So how might we solve for c? Well, to solve for c, we just have to square root both sides, right? So we get c equals the square root of x2 minus x1 all squared plus y2, this should be a subscript, y2 minus y1 squared. And that there is the distance formula. We just derived what is known as the distance formula. So the distance formula is defined as d, which is distance, equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. That's the distance formula. That's where it comes from. This formula comes from the Pythagorean theorem. Alrighty, so in the following examples, let's take the two sets of points and find the distance between them. So this is x1, y1, x2, y2. Distance formula is d equals the square root of x2. So we have 6 minus 4 all squared plus y2, which is 3 minus 2 all squared. And we get the square root of 6 minus 4, which is 2. So we get 2 squared plus 1 squared. 2 squared is 4, 1 squared is 5. So we get square root of 5. Here, let me write it out like this. So 2 squared is 4, 1 squared is 1, 4 plus 1 is the square root of 5. That's your final. For example B, we have the points -1, 4, and 6, -8. So to find the distance, I'm going to say D equals the square root of x2, 6, minus x1, -1. So we have 6 minus -1 squared plus y2, -8, minus y1, which is 4, all squared. So we get the square root of 6 minus -1. Well, that becomes 6 plus 1. 6 plus 1 is 7, so we get 7 squared plus -8 minus 4 is -12, so we get -12 squared. And this ends up becoming 7 squared is 49, 12 squared is 144, and 49 plus 144 is 193, so we get the square root of 193. Now, if you wanted to approximate, or if you were asked to approximate these answers, keep zooming out and in. If you were asked to approximate these answers, the square root of 5 evaluated directly into your calculator, you'd get approximately 2.24. And the square root of 193 is approximately 13.89. Alrighty. So for example C, I encourage you to pause the video and solve this word problem on your own. And assuming you have given it a go, let's go through it. So our word problem is a helicopter is dispatched from an emergency base at the coordinate point -3, 7 to evacuate a scientist trapped near the edge of a erupting volcano at the point 9, -4. Flames roar and ash clouds swirl. If the pilot flies in a straight path, how far must the helicopter travel to reach the scientist before it's too late? Okay, well, let's see. We want to know how far the helicopter must travel for this to reach the scientist before it's too late. Well, to do that, we're going to need to find the distance from these 2 points. So we're going to say that D is equal to the square root of x2, which is 9, minus x1, which is -3. And then we're going to add the difference of our y values. So we're going to have y2, -4, minus y1, which is 7, all squared. So we get d equals 9 minus negative 3 becomes 9 plus 3, which is 12 squared. And then we get plus negative 4 minus 7. That's going to be negative 11. So we get negative 11 squared. And all of this. 12 squared, that's 144. And 11 squared is 121. And then 144 plus 121 is the square root of 265. And to approximate so we can get a better idea of what this looks like, that would be 16.27. And this problem didn't really give units, but let's say it's in miles. And if you wanted if you were to be asked for the exact answer, the square root of 265 would be your exact answer, and your approximate answer would be 16.27 miles. Now, the one thing I do want to say is because this is a helicopter flying to a scientist, these 2 points would actually be inaccurate. You would actually need a 3D coordinate plane for this to be more accurate. So this situation isn't really accurate for this 2D plane that we've seen, and you actually would use the distance formula for 3D coordinates for this to be accurate.